whether planet or light unit, all mass discharged from the sun rises away from the sun until it finds its potential position, and then revolves around it in slowly expanding spirals until each discharged mass has expanded into disappearance. This volume is necessarily too brief to enter into all of the complexities of the systems of lower potential, such as those of the lithium, beryllium, boron, nitrogen, oxygen, and fluorine lines. For purposes of analogy, it would be more simple to confine this brief explanation to the potential position of our own solar system with which we are most familiar. Our solar system occupies a high potential position in its wave, a position corresponding in all probability to the position of the element manganese. Our solar system is a mid-tonal pressure wall erected near the apex of the positive cone of the wave, very close to the 4++ position of the carbon line. A later volume will contain a series of drawings which will define the approximate position of the solar system in its wave. By a study of these drawings, it will be seen that the zodiacal expansion of the solar ecliptic areas indicates with unerring precision the exact relation of this solar system to its point of ultimate north. The sun of this system is speeding through space at an inconceivable speed, ever tilting its polar rotation toward its ultimate point of north, and ever contracting its polar magnetic base as it nears its destination. The solar ecliptic is ever tilting and contracting its base toward and into the ecliptic planes of the cubes of motion, and contracting its area to a plane which will coincide with the solar equator. As our sun speeds spirally toward the point of north, it carries with it all of the planets which it has discharged. These planets, with all of the sun's radiative emanations, are swirling about the sun as one of the pressure walls of the cone of the wave of which our solar system is a part. If the cone of the wave were not an ever-bending one, the planets would all revolve in the same plane, and there would be no zodiacal expansion of approximately 16 degrees. When the exact position of this solar system is calculated in reference to its ultimate destination at the overtone of its wave, the orbit of Neptune will be one of its important measuring units. With the orbit of Neptune as a magnetic base and the center of the orbit as the end of a plumb line dropped from an assumed altitude as an apex, the position of the sun in relation to this point will tell us a marvelous story. When this operation is repeated with all of the planets, always being certain that the same assumed altitude is used in each case, the direction of the bending line of our wave can undoubtedly be closely approximated. If revolution of mass began at the south inertial plane and continues its outward journey in unbending cones, the laws of motion which govern orbital variation would be very simple to write and to comprehend. The ever-changing cones of the wave, their ever-changing axes, and their ever-changing magnetic bases, reflecting themselves in tonal inertial pressure walls and equatorial planes of evolving masses, give to the masses in motion all of their complexities of processional orbits and variation of ecliptic planes. We are accustomed to think of the orbit of a planet as a continuous and repetitive one of the same dimensions, instead of as a slowly expanding spiral, the repetitive revolutions of which so closely coincide that periods of thousands of years must elapse to mark a noticeable change. If the plane of this system were located as far toward the south in the cone of the wave as the 2+ potential position, orbital extension would be very noticeable in short spaces of time. Located as our solar system is, however, close to the apex of the positive cone of the wave, where the sun's speed is increasing in the universal ratio as it hurries into ever-increasing pressures toward its point of north, the increased pressures of the ever-increasing higher potential position towards which the sun is dragging the whole system practically offsets the extension of planetary orbits. The consequent gradual decrease of the zodiacal expansion also helps to offset orbital extension of planets. If revolution of mass is spiral, all orbits must be conic sections. If the pressures within the cones of the wave were evenly distributed in horizontal directions, even though unevenly distributed in vertical directions, all orbits would be practically true circles. The bending of the cones of the wave results in such unequal horizontal distribution of pressures that the conic sections in which orbits lie are in planes which conform to the variation of pressures. The reason for the decelerated revolution of the outer planets of a system and the accelerated revolution of the inner ones is very simple. Outer planets revolve in orbits further south, and inner planets revolve in orbits further north. Magnetic deceleration of revolution is toward the south magnetic basis of the cones of waves. Electric acceleration of revolution is toward the north apices of the cones of waves. In a high potential position, an orbit is very much restricted. A mass is very much contracted, and its weight, specific gravity, and density are very high. In this potential condition, it occupies a position very close to the gravitative radiative center of its system. A mass in a high potential position must cover an equal orbital area in the same amount of time as would the same mass in the same plane expanded to a low potential position. The high potential must therefore circle its sun 4 times to the one revolution of an equal mass in the same plane, but twice the distance from its sun. The accelerated or decelerated revolution of any part of an orbit is due to its eccentricity. Eccentricity. That's it. Every equal area of the orbit of any mass must be covered in an equal interval of time. Kepler's well-known second law of motion reads as follows. The radius vector of each planet describes equal areas in equal times, or the straight line joining a planet to the sun sweeps out equal areas in equal intervals of time. The orbit of Mercury is the most eccentric of the system. Consequently, there is a greater relative acceleration as the planet approaches its perihelion, and greater relative deceleration as it approaches its aphelion than of any other planet in this system. Among the comets where eccentricity is very great, the acceleration of the comet as it approaches the sun and its aphelion position of maximum deceleration might be likened unto the speed of the antelope as compared with that of the tortoise. Eccentricity of orbit. Why Mercury should swing around the sun is so great in so great an eclipse, why the orbit of Venus is so nearly perfect a circle, and why there should be a variation of eccentricity among the planets can be easily explained. It will be remembered that all mass moving on the outward journey to north is generative, and that all generative mass is accelerative in its orbit. All orbits are conic sections. A conic section, which is parallel to its base, is a circle. A conic section, which is slightly inclined to its base, is an ellipse of very little eccentricity. The greater the inclination of any conic section to the base of the cone, the greater the eccentricity of an orbit.